Hello and welcome to EELE 101, Introduction to Electrical Fundamentals. We often abbreviate the course title as Introduction to Electrical Engineering or Intro to EE. My name is LaMeres and I'll be your instructor this fall. In this intro video, I want to go over the course logistics for this fall because things are a little bit strange compared to a year ago. And so I want to walk you through kind of what to expect and kind of how to engage with this class. So first and foremost, due to COVID, we are using what's called a blended format. And what that means is that we have reduced capacity in all our classrooms. And so realistically, we just can't all fit in one room at any given time. And so what we're going to do is we're going to take steps to kind of try to spread out. But one of the things that I'm going to do is I'm going to try to create this course so that it can be offered either live or fully online. And that's going to give you the option to, if you don't want to come to campus, then I'm going to try to allow it so that you don't have to. So in addition to live lectures, I'm going to be recording lecture videos, and I'm going to try to design the labs and the recitation in order to be able to be conducted with a portable lab kit. So let's go over the course logistics really quick. First of all, we are going to be using a system called Brightspace. You're probably familiar with this by now. This is the course management system for MSU. It's essentially our website. So let's go out to Brightspace and let's log in and take a look at this course. So the web address to this is ecat.montana.edu, and you're going to log in with your NetID and password. Don't worry about this ECAT1, ECAT2 business. Whenever you type in ecat.montana.edu, it'll take you to whatever server is correct. And you're going to use your login, NetID and password. If you forget your password, go ahead and click on that link. A very common thing when you first start using this system. You're going to get taken to the kind of the start page for your Brightspace. And any classes that you have that are live are going to show up over here on the right under My Courses. And so right here, what you're going to see is you're going to see EELE 101, and you go ahead and click on that, and that's going to take you to what we call our course page. Okay. Now, when you come into here, you'll see kind of this, electricity going, and you'll see a little welcome screen right here. I just put this welcome screen here. It's an announcement, but I always like to have something that is greeting me when I come into the course. So I always just put like a small image right here, just so I know that I'm in the right spot. And so when I come in here, this is Brightspace. Okay. Now, the way that this works is you are going to have all the different tools within Brightspace that are listed up here along the top. And where we always start in this course is in content. Okay. So when you come over to content, what I do is I'm going to put all the information that you need to access as little activities or content pages over here on the right. And so when you come in here, you're going to see all the weeks laid out. But what I want to do in this course or in this video is just go over the course information and syllabus. So if you click on that, what you're going to first and foremost see is you're going to see a link to the syllabus. And so that's what we want to go over. We want to talk about how we're going to actually do this course. Also on this page, I give the most recent contact information for myself and also our teaching assistants. So we'll come back to this in a second. But we have a small team, small army actually, of teaching assistants that are going to be helping out in the labs and the recitation and with the grading in this course, because it is a relatively large and not a complicated course, but it's got more components to it than a traditional just sit in a classroom 3 times a week. Okay, so let's start with the syllabus. So if you click on that, you're going to be taken out to the syllabus. Okay, so here we are. And the first thing that you notice is the dates of this are going to run from the 17th of August to before Thanksgiving. Okay. And so we will be done before Thanksgiving, and then we have almost a 6-week break before the spring semester. And so so that's very important to know. This is going to feel a little quick. Okay. And so the course has been modified to accommodate this schedule. This course is about electrical and computer engineering and trying to understand what this is, what this profession is, why it exists, and its role in society. And I'm actually going to have a different video on that because I want to spend a little bit more time going into, what is electrical engineering. But this course is going to give you kind of, material to think about, exercises to do, but it's also going to have a laboratory component and a recitation component, which I will talk about in a second. I'm in the new engineering building, so Norm Asbjornsen Hall, up in 316, and my office is number C, or letter C. Email is the preferred way to get a hold of me. Here's my contact information. You can check out my website if you want to see some background on me. The prereq for this class is an introductory class, so we just want you to have, pre-calc. Okay, so basically algebra. We want you to be able to be ready to go into calc either along with this course or shortly after. Calculus is not used in this class, but we will be using, algebra. So, all right, so here's the big thing. We have 3 credits in this class, and one of the credits is a lecture, one's a lab, and one is a recitation. If you're watching this, you should be registered for all 3. You're registered for, there's different sections of lab, different sections of recitation, so you need to be registered for one of each. All right, so the lecture. What is the lecture? Basically, the lecture is where information about electrical engineering is conveyed to you via a person, okay? And that person is going to be me this semester. So in a traditional classroom setting, I'll be just sitting in front of a room talking. I might have slides, I might write on a board, but I'm just going to be explaining concepts about electrical engineering. You can also watch a video. So I'm going to try to make associated videos that will match what I do in class. I might also just record what I'm doing in class and then just make that available for people that maybe didn't want to come to class or maybe missed class for being ill. There will be homeworks associated with the lecture, but they're all going to be in the form of a multiple choice quiz. Okay, so there's no paper and pencil deliverables in this class. That's going to allow us to do this class fully online if necessary. Okay, the lab is where you are going to get hands-on experience building circuits and measuring electrical quantities. So you're going to actually be taking a breadboard. You're going to have to purchase a breadboard. We'll talk about in a second. You're going to build circuits, and then you're going to take measurements using portable test equipment. So you're going to have, you're going to basically measure voltage and current, resistance, continuity, using just equipment that you're going to be checking out. And so this is where you actually kind of see electrical engineering in action. So the lab will relate heavily toward the content that we cover in the lecture. Okay, so as part of that, what you're going to do is every week there'll be a handout or an introduction video, and then you'll do the lab assignment. And then what we're going to do is instead of having somebody come over and check you off to make sure you did it right, we're actually going to have the deliverables be videos. Okay, sometimes we can get away with pictures, but instead of a human looking at your measurements live, what we're going to do is have you take a short video and then upload that to Brightspace so that we can grade this later. And the reason we're going to do that, even if you do the labs on campus, where everything's going to be graded the same way, and if we do it with videos, you can actually do the lab anywhere. So that's going to allow you to do it remotely in a situation where if campus closes due to COVID, we're just going to continue marching along with this course schedule. And as long as we do everything as if it was going to be online, then it won't be a big shock if we do have to go fully online. Okay. Now, you do have a dedicated lab section, and these meet in Cobley Hall 602. And you got a 2-hour section in there, but like I say, we can't all fit. So what we're going to do is the last names, if you're a student with a last name that starts with A to L, you can come to the first hour of your lab section. If your last name starts with M to Z, you can come to the second hour. And these lab sections are made to be open help sessions. So if you want to work on the labs in there, that's fine. You can go in, watch the video, read the handout, and then do the labs. They're all going to be designed to be about 30 minutes. That's what I'm going to try to do. So you should have ample time to get in there and do the laboratory. But if you decide you're going to do it elsewhere, that's fine. But if you need help, this is when you can come get it live. If we flip online, what we'll do is we'll just have our lab instructors be available via Zoom or WebEx, okay, during these same times. So hopefully it's just going to have a flow where we can seamlessly flip between live and online. Okay, we'll talk about the equipment that you're going to need here in a second. The recitation. Recitation is designed to give you a programming experience. So the expectation is that you've never programmed a computer. If you have, the stuff we're going to do is probably pretty rudimentary. We are going to try to, well, we're not going to try, we are. We're going to teach you how to do very simple programs in a language called C. And we're going to start the semester by using just a standard computer interface. We're going to log into a campus server, and we're going to do command line programs using just basic text editors, and we'll do all the things like hello world, and we'll learn about if-else statements and loops and stuff like that, input output, and we'll do that for about 6 weeks. Then what's going to happen is the recitation is going to switch over to programming an Arduino microcontroller or microcomputer. And so you'll start actually writing C programs. So it's not exactly C, but it's pretty close. You're going to be writing programs for this little fella. This is the Arduino Uno. And you will purchase this thing as part of a robotics kit. And as soon as you start programming that, what's going to happen is you will start building up a robotic platform. And each week you'll add a little bit more and more to this robot, and it's going to give you experience kind of learning about some of the things that we're learning about in electrical engineering. Things like batteries and power supplies and regulation, things like LEDs and resistors, things like sensors and digital touch sensors and things like that, and also motors. And so as this thing builds up, you're going to have a robotic platform that your last assignment for the semester is going to be having this thing autonomously follow a line on the floor and then stop when an object is in front of it. So that's the culmination of this entire, actually class, but that's kind of the recitation component of it. What will happen is the last few weeks of the semester, the lab will stop, and you'll have that extra time to actually work on your recitation because it will get more and more time consuming as we go. You are registered for a recitation section, okay? Same thing though. You have a 2-hour recitation, but we can't all fit in the rooms at the same time and socially distance. So we're gonna have last names A to L, come to your first hour, M to Z, come to the second hour. We'll have our teaching assistants in there to help, and they are designed to be open help sessions. So you're going to have you will have a video that you watch to learn about the programming constructs. Then you're going to do a little, pre-recitation quiz. Then you're going to actually code it up and run your program. And we will demo that using a short video. So you will upload a short video, and it'll be interesting because, your short video, everything's taken with a phone. You're going to be taking a video of, here I am typing on here's me running my program, hello world, and that's it. So you can demonstrate your program in five seconds. And then what you'll do is you upload your code, and we'll be able to look at your video and also your code, and then be able to give you a grade that says that you actually did the assignment. So again, it's designed to be fully online if needed. The recitations are open help sessions, so we will have people in there that can help you. And if we have to go live or if we have to go online, what we'll do is we'll just have the teaching assistants in there be on WebEx or Zoom, okay? All right, so we are sitting right here, course website, we already went over that. The learning outcomes for this, I won't go through these because you really probably don't know what any of this stuff means right now. So when I say set up a function generator, you might not know what that is. So it's kind of silly to talk about all this stuff you're going to learn. This is what you're going to learn though. So if you go through this list, maybe at the end of the semester when you look back at this, you'll be like, oh, that's pretty sweet. That's pretty sweet. One of the big parts of this class though is that I'm trying to give you it's more of a taste of electrical engineering, but it's also a taste of different ways that courses are structured. So it's nice to see videos of an instructor. It's nice to see an instructor live. It's nice to see a laboratory experience or to have a laboratory experience, a programming experience. So this course kind of touches on a whole bunch of different modes of delivery that you'll see while you're in college. And so that's another kind of aspect of this course, is to just kind of engage you in the whole college experience. Okay, times and locations. There is one lecture, which is Norm Asbjornson 201. It's also Inspiration Hall is the other name for it. And we meet 3:10 to 4 o'clock on Wednesdays. So that's the 1 hour of lecture. And then there's sections of lab and sections of recitation, and they vary by the students. But all the labs and recitations meet in Cobley 602. Okay, now we get down to required materials. Textbook, no need for a textbook. You're going to have to purchase some lab materials that are they're not cheap, okay? So we don't have you buy a $200 textbook. What we'd rather have you do is use that money and buy something that's kind of cool that you can hang on to and actually use in different classes. So no textbook for this. The lab supplies that you will need it's going to be a combination of some stuff you have to purchase, okay? Some stuff you're going to check out, and then some things you're going to be given for free. So let's go through what you need to purchase. So you need to purchase a large breadboard. This is a breadboard, okay? And when you buy this, it comes with a bunch of wires that you can actually, build circuits on. So we sell these in the EC stock room, which is 622 Cobley Hall. They're about $20. And if you're a EE student or a CPE student, computer engineering, you want a big one because you're going to use this in almost every class throughout your entire curriculum, okay, throughout your entire degree. So you want the big one. If you're a non-EE or CPE student, you can buy the small one. That's fine. And we do sell them for about $20 in the stock room, but you can also buy them anywhere. If you already have one, that's fine. If you find one on Amazon that's cheaper, that's fine. If you have a buddy that you can buy it used from, that's fine too, okay? Let's see. That is you're going to purchase, and you need to purchase that essentially in week 1 or before the first lab period. So you can't do the first lab until you have this breadboard because the first one's going to show you what to do. Now, you are also going to purchase a robotics kit, okay? And this is from, it's a company called Prereq, but we purchase these and then we sell them through the stock room. You do not need to purchase this on day 1. In fact, don't purchase this on day 1 because we haven't got the final order together yet. You need to purchase this in week 6 of the semester. So by week 6, we're going to try to figure out all the parts that need to go with this to try to get you the lowest cost. But it's still going to be about $160, okay, for engineering students. The reason it's $160 is it's actually more expensive, but we use some of your program fee dollars to get the cost down on this. And it comes with an Arduino, but we'll get all that kitted up for you. But you don't purchase that in the first week. Only purchase the breadboard in the first week, okay? That's it. That's the 2 things that you're going to need to purchase. You are going to check out some things. So we're going to check you out some equipment, and you don't have to do this. We'll give you more information in the first laboratory, but you're going to check out a multimeter, which is going to allow you to measure voltage and current, but you have to bring this back, okay? So you can't keep this because we need this for other classes. But everybody's going to check one of those out. Then we're just going to give you some things, and we give you electronics that basically we don't want back because they break. So we're going to give you little things like resistors and LEDs and batteries and stuff like that. So the 3 kind of groups of lab supplies are, you got to buy some stuff, we're going to check you out some stuff, and then you're going to be given some stuff, okay? And between all that, we will be able to accomplish the lab and the recitation. Okay, grading scheme, I'm a straight grader, so 90 and above is an A. 80 and above is a B, 70 and above is a C. I don't give pluses or minuses. I'm caught up on this whole thing where there's not an A plus. So how can you get a 92% in a class and have that be an A minus? But if you get a 98 in a class, it's not an A plus. So I tend to not like the minus system. So I just grade straight. In sometimes strange situations, I might give a plus or a minus. So I say I reserve the right. But anyway, that's going to be how the grading is done. And we'll go through on the last page of this. I'm going to jump through the academic policies and come back to that in a second. On the last page, I give you the detailed schedule for the course. And what you're going to see here is I break down the points in here as lecture, lab, and recitation. And you'll notice that like in week 1, which is what we're in, there's no assignment. Okay, there's no homework for a lecture, there's no lab, there's no recitation. I do give you an extra credit opportunity. Read through the first page and I have a document on how to email like a pro. And if you fill out a quiz, you can get 2 points of extra credit. The point system in here is there's 100 points available. Every assignment is worth a certain number of points. But obviously, they're going to be 1 point is 1%. But this is an example of like what the weekly flow might look like. If we jump to week 2, you're going to have a lecture. Then you're going to have a homework in the form of a multiple choice quiz, and that thing is worth 1 point. Then you're going to have a lab. You're going to have a pre-lab that you need to do, which is basically you're going to read the handout or watch the video. Then you do a short quiz just to make sure that you got the basics of the pre-lab. Then you'll actually do the lab and you'll demo it. But like I say, you're going to take a video of it or pictures, and you'll demo it that way. Then in the recitation, same thing. You're going to watch a video, you're going to take a pre-recitation quiz, then you're going to do a program and demo it, and then we need your code. So you actually have another little point here that's for your code, just to make sure that you're turning in, first of all, it's your program, but also we want to check it to make sure that you're doing it the way that we want you to do it. Okay, for a given week, the homework, all the assignments are due the next week at 3 p.m. So you have your weekly time, you have a full week to actually do the assignments, lecture, lab, and recitation. And you have your lab times, you have your recitation times to do that. Then what I do is I said, okay, if you didn't finish it, you should be able to finish it if you use that time. They're all designed to be like 30 minutes of activity for the homework, for the lab, and for the recitation, so 30 minutes each. But if you don't get through it, we give you the weekend, and then we give you Monday and Tuesday and a little bit of Wednesday to ask questions and get more help. Okay, so that's everything is due the following Wednesday at 3 p.m. And I put 3 p.m. because that's basically the start of class for the next week. Anyway, so then if you look at the next one, same type of thing. It's just you have a lecture, you have a homework, you have a lab, you have a pre-lab quiz and a demo. Then you have a recitation, you got to watch a video, do a prereq quiz, do a demo, do a code upload, and those are then due the following Wednesday. If you march through this, it looks very repetitive, and it is, and it's on purpose. We want to have this thing be, consistent so that everything makes sense. Once you get down into week 12, what happens is that the labs will stop. We do 10 labs. The lab will stop, and we're going to do a module on engineering ethics and the role of engineering in society. And then you're going to have kind of a larger project where you actually get the robot to follow a line on the floor. And we're going to give you a couple weeks to do that. During week 13, Veterans Day falls on a Wednesday. So that means we don't have lecture, and we don't have any of the recitations that meet on Wednesday. So we won't have any recitation or any lecture. We do have lab open for you to use. No new lab assignment, but you can use those hours to actually work on your recitation assignment. And then what happens is this course is going to end on Wednesday, the 18th of November. Now that is not the Wednesday before Thanksgiving. That is before that. Okay, so we end this class earlier than all your other classes, so to give you time to do the finals in the other one. So this is the entire course as it is right now. Okay, so that's kind of what you're going to do. So when you get done with this video, you're going to go watch another video on what is electrical engineering, and there's no assignments. Okay, so this week there's no assignments, and you know that by looking at this. Sorry to be scrolling so fast, but there's no assignments for this week. Once we come to week 2, you will start getting the assignments, and you can get into kind of this rhythm of what this course will be. Okay, let's talk about the undesirable stuff, academic policies. All right, so here's the academic policies. The biggest thing you notice is it's mask time, right? So COVID, everybody decided you have to wear masks. It's public safety. It's a requirement at Montana State. By the time you listen to this video, I'm sure you will have heard this probably 10 times by 10 other instructors, and so I will go through it quickly. But you can't be in any of the buildings without a mask, and it's mandatory. Okay. Basically, what happens is they've designed the policy at MSU so that the instructors like me, there's no confrontation. Okay, so this isn't like a thing where I'm going to get in if you don't wear a mask, I'm going to get in an argument with you. It's just going to be a quick resolution of what I'll do is I'll ask you, do you have a mask? And if you don't, I'll offer you a mask that I'll bring with me, the disposable mask. If you don't wear the mask, then I'll ask you if you have an accommodation from the disability services. And if you do, you show me your accommodation, and then that's fine, and you can not wear a mask. If you don't have the accommodation, then I have to ask you to leave the class. And then if you don't leave the class, then I dismiss the class. And then we just call it a day and everybody watches the video. So that's the policy. It doesn't really matter if I like it or if you like it. It's just that's the rule. And they came up with this really quick guide of just like, ask to wear a mask, you won't. Leave the class, you won't. Class dismissed. Okay, so that's basically it. It will take 5 seconds to resolve any issues because we just immediately cancel class or have the student leave. Okay, so that's it. Let's see. Collaboration and cheating. You are encouraged to work together because there's no engineering problem that can be solved alone anymore. Okay, so you will work with people, work with your classmates, meet new people, exchange ideas. You can't cheat though. What cheating means is that you turn in somebody else's work. So if you both are working on a program like your recitation, don't have one person code it all up and then email it to everybody else. What you need to do is everybody codes their own, even if you're working together and saying, oh, you should try this structure, you should try this data type, but everybody codes themselves, everybody uploads their own work, but you're encouraged to collaborate. So that's what the difference between collaborating teaching is and just flat out cheating. Okay, so that is it. Once again, welcome to this class. You're sitting in the first electrical engineering class probably of your life. A lot of things have happened that have led you to this point. Okay, this just didn't happen accidentally. You just weren't sitting there watching TV and looked at the remote and said, I wonder how a remote works, and I'll just go to college for 4 or 5 years and figure it out, and then I'll feel happy. It's like a lot of things have happened that have put you on this path, and so I applaud you for taking this class, and I hope that it works out. We need more engineers. We need more diversity in engineering. We just need more engineers to solve the world's problems. So I'm very happy that you've taken this next step. So that's it for now, and I look forward to working with you this semester.